Solve b in this equation. Solve for b means we want to isolate b. So our final answer should be b equals something. So then what we have to do is we have to actually isolate the term with b first. That means that negative 6k over b should be one side of the equal sign, and everything else should be in the other side of the equal sign. So how do we do that? First, we subtract 2r both sides. Then what we have left is negative 6k over b equals 9 minus kr minus 2r. Now our goal is to isolate b. That means b should be multiplied both sides. So the way we look at this here is that the one on the right side is entire one equation. So we multiply b both sides like this so that these b's cancel out. And what we have left with is negative 6k equals the entire thing 9 minus kr minus 2r times b. Then now we can isolate this b by dividing by 9 minus kr minus 2k. So we divide this by both sides. So then we have negative 6k over 9 minus kr minus 2k equals b. So we can also write in another direction, b equals negative 6k over 9 minus kr minus 2k. So this is our final answer. Solving for b. Solve for a in this equation. So if you look at here, we have actually two a's, ka and 7a. So we have to put all the terms with a in the one side of the equation and all the terms without a in the other side of the equation. So what we actually do is first, we can just subtract ka both sides like this. So then what we have left, let me write here, 7a minus ka minus k over r squared equals 24. Oops, k right here. The next, what we do is we add k over r squared both sides like this. We do this so that all the term with a is in one side of the equation and everything else in the other side of the equation. So 24 plus k over r squared, like this. So then if you look at here, we have a and a. So we actually have to factor a out. So a would be 7 minus k equals 24 plus k over r squared. Now, in order to isolate this a right here, we have to divide both sides by 7 minus k, because 7 minus k is multiplied to a, and we can undo the operation by dividing. So let me write that here. We divide both sides by 7 minus k like this. 7 minus k. Let me write the final answer here. Next step right here. So then a equals 24 plus k over r squared divided by 7 minus k. And maybe this looks a little messy since we have fraction over fraction, or fraction over fraction within a fraction. So we can rewrite it 24 plus k over r squared. Entire thing multiplied by 1 over 7 minus k. Like this. And we can actually also multiply these out, distribute. So a equals 24 over 7 minus k plus k over r squared times 7 minus k. So this is our final solution. A equals this. So which of the following are equivalent to u to negative 6 power raised to 4th power? This, so let me write it here, u to negative 6 to 4th power is same thing as u to negative 6 power 4 times, like this. Which means we have u to the negative 24 power. So we want to see which one of these is same as equivalent to the original one. So just to start, we can tell that this is okay, right? This is same as if we multiply negative 6 and 4, which we get here. So this is a good one. So now this one, let's simplify one at a time. This one right here simplifies to u to the second power. This one is same as u to the 6 times u to the negative 4, because positive x1, when it comes to the numerator from the denominator, becomes negative, which is u to the second power. Okay, so this is also not it. Now let's look at this one. This one, we can rewrite it as u to the half power, because square root is same as half power, times u to the negative 23. So we can simplify to u to half minus 23. Let me rewrite it this way. So this one we can rewrite it u to the half minus 23, which is again not same as negative 24. And lastly, this one is same as we can multiply this number, negative 24. So final answer is these two, right? This one and this one. They're equivalent. Write as a single fraction and simplify. So we're adding two fractions. So let's rewrite it here. 3 over a squared minus 3a plus 2 over a squared minus 9. So what we can do is when we add two fractions, we need to have a common denominator. Okay, so in order to do that, what we can do is we can actually factor bottom, which is a minus 3, plus 2 over, this is same as a plus 3, a minus b. Oops, sorry. A minus 3. Let me write it better there. So this right here, let me explain real quick. This right here comes from the generic a plus b times a minus b equals a squared minus b squared. So we can think 9 as 3 squared, and that's what we get this right here. So then we look at this both fraction, both as a minus 3. So in order to have a common denominator, on the left side I have to multiply a plus 3 over a plus 3. And actually a plus 3 over a plus 3 is 1. So the quantity is 1. So we're actually not changing the quantity. We're only just changing how it looks. So we're multiplying 1 here. And then on the right side, we need to multiply a over a, so that denominator will have a plus 3, and a minus 3. So now we have a common denominator. On the denominator, we have a plus 3, a minus 3. Same here, a plus 3, a minus 3, a. So we simplify in the bottom. Since it's a common denominator, we only need to write it once, like this, over, now on the numerator, here I have to distribute 3. So I get 3a plus 9. Here I get a plus a times 2, which is 2a. This is 9. So 3a plus 2a gives me 5a by collecting like terms, plus 9 over a times a minus 3 times a plus 3. So this is the final answer, where we combine, we add two fractions, and we simplify. Rationalize the denominator and simplify. So in this expression, this denominator right here is not a rational number because of square root 3. So what we can do is, let me rewrite the equation or expression first. We multiply by 1 minus square root 3 over 1 minus square root of 3. So this is sometimes called fancy 1, where this is 1 over 1 essentially cancels to 1, right? Simplifies to 1. So we're multiplying 1, which means we're not changing the quantity. We're only changing how it looks. So when we multiply this, we get 2 minus 2 square root of 3, because we're distributing 2 right here. And we have 1 minus square root of 3 square, which gives us 2 minus 2 square root of 3 over 1 minus 3, which gives us 2 minus 2 square root of 3 over negative 2. And we can simplify furthermore. Now, negative 2 can be seen as a common denominator, so we can separate it. 2 over negative 2 minus 2 square root of 3 over negative 2, which can simplify to negative 1 plus square root of 3. So this is the final answer where we rationalize this expression, this given expression. Find the domain of f of x equals 4 over x plus 7. So we're finding the domain of this function. So when it's function in this fraction form, we see what x value we cannot have. So if you see here, if you plug negative 7 here, we get 0 in the denominator. And we cannot have 0 in the denominator. Therefore, on the domain for this function, we have to exclude negative 7. We must exclude negative 7. So the way we write this domain is, sometimes it's helpful to write a number line. Here's negative 7. So everything else from negative infinity to negative 7 is fine. And negative 7 to greater than negative 7 is fine. So anything in this range right here is fine. We do different color. Like here is fine. And this open parenthesis is excluding. Excluding and all the way up to positive infinity. So let's write that in interval notation. So domain is negative infinity to negative 7. For infinity, we always put open parenthesis. And here, in this case, we exclude negative 7, so we put open parenthesis. And this union means also n, and also negative 7 to positive infinity. So this is one way to write it. We can also write in self-builder notation, where we write a set of numbers. In a bracket, x such that, this vertical line is such that, x such that x is not equal to negative 7. So this right here is saying that set of numbers such that only x equals not negative 7. But anything but negative 7 is fine. So these two are the domain of this function, and just two different ways of writing it. And we need to be able to write both ways. Find the domain of function f of x equals square root of 1 minus x over x minus 5. So when we have an input variable in both numerator and denominator, we need to look at both top and bottom. So in this case, what we do is we look at f of x equals square root of 1 minus x over x minus 5. So let's look at top first. We know that square root cannot have negative number inside, but 0 is okay. So that means that inside of square root, which is 1 minus x, must be greater or equal to 0. So numerator alone tells us that 1 minus x must be greater or equal to 0. So we can solve for x by adding x both sides. Then we get 1 is greater than or equal to x, which we can write as x is less than or equal to 1. So numerator alone tells us that the x must be less than or equal to 1. Then let's look at the denominator right here. This tells us that just x cannot equal to 5. You cannot have 0 on the denominator in a fraction. So here it gives us two restrictions. x has to be less than or equal to 1, and x cannot equal to 5. So what we do is we draw a number line and combine these both restrictions. So here is 1, and here is 5. So it has to be less than or equal to 1. That means it has to be including 1 and less than or equal to. Anything is fine. But it also has to exclude 5. So if we open parentheses. But since x already has to be less than or equal to 1, 5 is already not included. So for this answer, all we will have to worry about is writing this part, which is in interval notation is negative infinity to 1, including 1. In separate notation, we can write x such that x is less than or equal to 1. So it's always helpful to draw a number line. Again, the 5 is already excluded when we write x is less than or equal to 1, or in this range, 5 is not included. Find the domain of f of x equals x minus 3 over x squared plus 9. Here again, we have a input and output on both numerator and denominator. So we look at separately. So if you look at separately here, we can have any value. 3 is also okay because we can have 0 on the numerator. So there's no restriction in here. Denominator, x squared plus 9. We cannot have 0 on the denominator. Only way we can have 0 on the denominator in this case, when x squared gives us negative 9. But since we're squaring a number always gives us positive number. Therefore, this also does not give us any restriction. We can have any number. So for this problem, the final answer is just all the real numbers. So negative infinity to positive infinity. And we can also write x such that x is all real numbers. So there's no restriction. Any number you try to plug in, it will always give us a number. Nothing can be undefined in this case. So there's two ways of writing answer right here. Find the domain of f of x equals square root of 9 minus x squared over x. So again, let's look at denominator and numerator separately. Then we'll combine the restrictions together. So here, we know that under the square root, we cannot have negative number. But 0 is okay because square root of 0 is 0. So 9 minus x squared must be greater or equal to 0. Then we solve for x. We add x squared both sides. We get 9 is greater than or equal to x squared, which means x squared has to be less than or equal to 9. Okay. So when is this true, right? When 3x is less than equal to 3, this is true, right? When x is 3, we get 3 squared is 9. When x is 2, we get 2 squared is 9. So all the value less than 3, but also all the value must be greater than negative 3. Because for example, if you square negative 4, we get 16, which makes this expression incorrect. So x has to be less than or equal to 3 and greater than or equal to negative 3. And we can combine that and write like this. Because we're squaring, if we square any number smaller than negative 3, such as negative 4, negative 5, once you square those numbers, we get bigger than 9. But we want less than or equal to 9. Okay? So restriction from the numerator is that it has to be between negative 3 and 3, including negative 3 and 3. Now denominator just cannot be 0. Since there's not adding or subtracting, we know that x just cannot equal 0 here. So we have to combine these two restrictions. So let's draw a number line and mark this number 0, negative 3, and 3. If we look at this, it can include negative 3 all the way up to right before 0. We cannot have 0, so exclude 0, and also exclude 0 and all the way up to 3. So if I write that in interval notation, the final answer is -3 including to 0 union 0 to 3 close bracket. And if you write in interval notation, separate notation, we can write x such that x cannot equal 0, and also write just this expression we found right here. So these two are a way to write the final answer. So in this case, we're taking square root of entire fraction. We're dividing inside first and then taking the square root. So here, when we approach this kind of problem, when we take a square root of entire fraction, we draw a number line, okay, like this. And we're going to plug some numbers to see which one result a negative number, which we cannot have, and which results positive number, which we could have. So the way we mark the number line is, first, we know that we cannot have -2 and +2. Because if I do -2, I get 0 on the denominator, which is undefined, and same for 2. We're also going to write 5. 5, we can have it, but 5 makes 0 on the numerator, which is fine. But in order to find the intervals, we need to write 5 here. So whatever makes 0 on the numerator, whatever makes 0 on the denominator, we mark in a number line. And the way we approach this problem is we look at these 4 intervals, 1, 2, 3, 4. In these 4 intervals, we pick a number and plug in both numerator and denominator. And if it gives us negative or positive over positive, that's okay. But if it's negative over positive or positive over negative, we cannot have, because we cannot have a negative number on the square root. So we pick a number. Let me try right here. For example, if I plug -3 in the numerator, I get -8, which gives me a negative number. So in this interval, whatever number I plug into numerator, I get a negative number. Denominator, if I plug -3, I get positive, because I get 9 minus 4 is positive. So on this interval right here, from -infinity to -2, whatever I plug in this interval, I'll always get a negative over positive, which means we cannot have that as part of the domain, because they'll give us a negative number as a result. And we cannot take a square root of negative number. Okay? So we exclude that, and we could keep doing this for all the rest of the interval. For example, if I can plug 0 here, then I get -5 on the top. So let's just write a negative number. Denominator is also negative. So this is okay. We get a negative number over negative number, which is positive. Then we take the square root. So this will get a positive. Then we take the square root, which is okay. We're taking a square root of positive number. So then let's look at between 2 and 5. Pick a number. Any number is fine. 3, 4, 4.1. So if I plug 3 in, I get a negative number. And I get positive number. So that is not okay. We exclude. Lastly, we plug number here. Let's pick 7. I get positive number. I get positive number. So that's okay. So only okay interval is -2 to 2 and 5 to infinity. Okay, so let me explain the final answer. We do have to be careful. It's from -2 to 2, open parenthesis, because we cannot have -2, because if we have -2 or 2, we get 0 on the denominator. That's why we write open parenthesis here. Union, we do write close parenthesis at 5, because it is okay to have 0 on the numerator. 0 divided by a number is 0. So that's why we do close parenthesis all the way to infinity. So this is a way to write a final answer. To write a final answer in interval notation. We can also write it in a separate notation. X such that x is between -2 and 2, and x is greater than or equal to 5. So for this problem, we have to look at which interval gives us negative number inside of square root first, and then exclude those intervals. Find the domain of this function. Again, function can be expressed not only in graph and equation, but also in a table. So here, domain is just x values, -1, 2, and 4. So domain, we just list those in a set builder notation. -1, 2, and 4. Those three numbers domain. And that's it. Just three numbers is domain. Whereas other problems we looked at, we have infinite number of domain. Right? When we write in an interval notation, is all the numbers between those intervals. Where here we only have exact three numbers as a domain. Find the difference quotient for function 3x squared minus 5x plus 4. So difference quotient is this expression right here. So f of x plus h minus f of x over h. So what I suggest you do is first write f of x plus h first. So f of x plus h, that means instead of x right here, we have to write x plus h as an input. So we do 3 square minus 5 times plus 4. Now input is not x anymore. Entire input is x plus h. X plus h, x plus h. So then simplify this by multiplying out. We get x squared plus 2xh plus h squared minus 5x minus 5h plus 4. Then we get distribute 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 4. Now this entire expression right here represents f of x plus h for this function. So let's write it in difference quotient form. So instead of f of x plus h, I'm going to write this entire expression I just found. This entire thing minus f of x. F of x is just this given equation. So just copy that down. 3x squared minus 5x plus 4. Divide by, entire thing divided by h. So we just expressed difference quotient. Now we need to just simplify. When we simplify, important to remember is distributing this negative sign. So distribute the negative sign. So let me copy this right here. And distribute negative sign, we get minus 3x squared plus 5x minus 4 over h. So that we can see that some stuff will cancel out. 3x squared minus 3x squared will cancel out. 5x, negative 5x, positive 5x cancel out. Positive 4, negative 4 will cancel out by doing collecting like terms. So what we have left here is 6xh plus 3h squared minus, right here, 5h over h. We can simplify one last step. Each of this term has h, one h at least. So we can simplify it to 6x plus 3h minus 5. So this represents difference quotient for this function right here. Find the difference quotient for a function f of x equals x minus 3 over x. So let's write it first. So f of x plus h, so instead of x, we write x plus h minus 3 over x plus h. So this right here represents this right here. Minus f of x is just x minus 3 over x over h. So let me maybe write here, this right here represents f of x plus h. This is just f of x. We wrote it with given equation. So now in order to simplify this, first we have to simplify the numerator. We have to have a common denominator. So on the top, we multiply x over x. Here we multiply x plus h over x plus h. So that we have a common denominator of x times x plus h over, now we're multiplying x to here, so we have to distribute. We get x squared plus xh minus 3x minus x minus 3 times x plus h. Entire thing over h. So we do also have to multiply these out. So let's do that. The next line. We get x squared plus xh minus 3x minus x squared minus 3x let's see. Let me actually do it this way. Let's do x first. X squared plus hx minus 3x minus 3h over x plus h, entire thing over h. Now here, when we simplify, we do have to distribute negative sign here. So let me write that in the next line. We get x squared plus xh minus 3x minus x squared minus hx plus 3x plus 3h over x plus h, entire thing over h. Now we can collect some like terms. Negative 3x and positive 3x will cancel out. X squared and negative x squared will cancel out. And also xh and negative hx will cancel out. Hx is the same as x times h, right? Multiplying. For multiplication, order doesn't matter. So this is the same as negative hx. So these two cancel out. Right? So only thing we've actually left with was this 3h. So let me write the next line. We get 3h over x times x plus h, entire thing over h, which is same thing as dividing by entire thing h is same thing as multiplying by 1 over h. And as you can see, this h cancels out. So final answer is 1 over x times x plus h. So this function, or this expression represents difference quotient for this function. Given the table below, determine the following. So here, before we look at these 4 problems, let's look at simpler one first. So this is the function given in table. For actually, we're given 2 functions, f and g. So for example, f of 1 is when x is 1, output of f is 2. And for example, another example, g of 3, then is when, this means input, when input is 3, the output for g is 8. So this is 8. Okay, so that's what we're doing. But here we're doing composite function. So g of 2, when x is 2, the output is 3. So we have f of 3. Now what is f of 3? When x is 3, f output is 0. So we go inside first. Again here, f of 1. f of 1 is 2. So we're finding g of 2. What is g of 2? Is 3 according to this table. When x is 2, g output is 3. Now for this one, we're going inverse. That means that this should be the output. What input give us output of 2 for f? Okay, so this input of x give us output of 2. So here we're going 1. So this is going opposite. This right here represents output. What is this inverse sign? When we see inverse, that's representing this is output. Inverse output. So which input gives us output of 8 for G? Right, so go G. This is the output. Input, corresponding input is 3. So that's just 3. For this problem, given two functions, f of x and g of x, find adding, subtracting, and multiplying. So adding function means we just add this. This means add two functions. So we do negative x squared plus 3 plus 3 over x minus 1. That's it. We add two functions. Subtracting means negative x squared plus 3 minus 3 minus x minus 1. And we can distribute the negative sign. So we have negative x squared plus 3 minus 3 over x plus 1. Now this means multiply. So we multiply negative x squared plus 3 times, make sure to write parentheses, 3 over x minus 1. Then we can distribute like this and this to get, let's say, negative 3x squared over x plus x squared plus 9 over x minus 3. Okay. Let's see. Yeah, so in this case, we can cancel out this x. Not always we can cancel that in functions, but for now, we could cancel for this one. So this is the final answer. So the next problem is continuing. Now we're using the same functions, but we're composite. This open circle means we're compositing these two functions. So particular for this one, we're doing f of g of x. So that means that function g is behaving like behaving as an input for the function f of x. So that means that for instead of x, we're inserting this entire expression as input. So instead of this x, we're to input this. So we could write it like this. F of x and g of x is 3 over x minus 1. So then this equals to, instead of x, we write negative 3 over x minus 1, entire thing square, plus 3. Yeah, and we can simplify this. Let's square 9 over x squared minus 6 over x plus 1 plus 3. Distribute negative sign. We get this as our final answer for f of g of x. Now g of f of x, now this was different. We're going different order. Now we're doing g of f of x. So outside function is g and inside function is f of x. So that means f of x is the input. So if I write this, we get 3 over f of x, which is negative x squared plus 3 minus 1. Again, as you can see, this is the input. Instead of x, instead of this x right here, we're putting entire f of x as an equation. So this is the final answer for g of f of x. So g of f of x and f of g of x is not always same. And if both of them are equal to x, and then we can say f and g are inverse to each other. Find the inverse function of k of x equals 2x minus 6. When we're inverting a function, we're inverting domain and range, input and output. So we're switching input and output. So just for convenience, instead of k of x, we write y, and we write the equation. And again, what we're doing is we're switching input and output. So output becomes input, input becomes output. That's why we switch y to x and x to y. And then we solve for this y right here. So add 6 both sides, we get x plus 6 equals 2y. Divide by 2 both sides, and y equals x plus 6 over 2. But for final answer, we should not leave it as y. We need to leave in terms of k of x. Well, it's not actually k of x since what we found is k inverse. It should be k inverse of x equals x plus 6 over 2. So this is the inverse function of this function right here. And we can always verify it by composing it. F k of k inverse of x should simplify to x. And also k inverse of k of x also will simplify to x. So what I'm saying here is if I do 2x minus 6, and if I composite these two, right, if I composite these two functions, want to simplify, I'll be able to simplify to x for both cases. Okay, so we can always check our answer for finding inverse functions. Find the inverse function of f of x equals x cubed minus 1. So instead of f of x, we can write y equals x cubed minus 1. Now we're switching domain and range. So y, we write all the y's to x and all the x to y. Now we're solving for this y right here. So then we have to add 1 both sides. We get x plus 1 equals y, the cube power. And we can take the cubic root both sides, like this, to isolate y. The final answer, again, we don't leave in y. We have to write in terms of f inverse equals cube root of x plus 1. So this is the inverse function of this function. Make sure to write in this inverse notation as for the final answer. Find the inverse function of h of x equals x minus 3 over x. So we have, instead of h of x, we can write y equals x minus 3 over x. When we're inverting domain and range. Since this represents output, range, this becomes input x, and this x becomes y. Then here now, we're solving for this y right here. So first we multiply y both sides. So we get xy equals y minus 3. Since we want to solve for y, we want to have all the terms with y in one side of the equation and other terms in the other side of the equation. So we can do that by subtracting y both sides. We get xy minus y equals negative 3. Let me come here. Now here we can factor y like this. Then we get parenthesis x minus 1 equals negative 3. Then in order to solve for y, we have to divide by x minus 1. Then y equals negative 3 over x minus 1. So we're almost there. But instead of y, we have to write in terms of the inverse notation. So h inverse of x equals negative 3 over x minus 1. So this right here is our final answer.